The morning of November 24, 1944. Tokyo, Japan. Air raid sirens wailed across the capital for what would become a daily ritual of terror, but this time, something was different. Radar operators at Matsudo Air Defense Station tracked incoming formations at altitudes their instruments had never recorded before. The contact reports seemed impossible. American bombers at 31,000 feet, cruising toward the city at speeds Japanese interceptors could barely achieve in level flight at half that altitude. Captain Teruhiko Kobayashi of the Imperial Army's 244th Sentai scrambled his Kawasaki Ki-61 fighters, climbing aggressively toward the silver contrails, scratching lines across the cold November sky. His engine gauges told a story he didn't want to believe. At 25,000 feet, his Kawasaki Heian fighter that had seemed so powerful at medium altitudes now struggled to maintain climb rate. The Nakajima Ha-40 engine, rated at 1,100 horsepower at sea level, was producing perhaps 60% of that power in the thin air. Above him, impossibly high, the American B-29 Superfortresses droned toward their target, operating in a realm where Japanese fighters simply could not function effectively. This wasn't just a raid, it was a demonstration of technological superiority so complete that Japan had no answer for it. The question that would haunt Japanese military planners for the remaining months of the war was already forming in Kobayashi's mind as his fighter gasped for air at 28,000 feet, still 3,000 feet below the bomber stream. How had America created aircraft that could operate where Japanese fighters suffocated? The answer lay hidden within each B-29's 4 massive Wright R-3350 engines. 8 devices that Japanese engineers had tried desperately to replicate and failed completely to produce in useful quantities. General Electric Turbo-Superchargers, the mechanical advantage that turned altitude itself into an impenetrable fortress. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The technological divergence that would doom Japan's air defenses began years before the first B-29 appeared over Tokyo. In the mid-1930s, American aviation engineers faced a fundamental problem. Piston engines lose power at altitude because air density decreases. Less air means less oxygen for combustion, which means less power. By 20,000 feet, an unsupercharged engine produces roughly half its sea-level horsepower. At 30,000 feet, it's down to a third. This wasn't a problem unique to America. Every nation developing high-altitude aviation confronted the same physics. The solutions diverged based on industrial capability and engineering philosophy. Germany pursued mechanically driven superchargers, devices connected directly to the engine's crankshaft that compressed intake air. The system was simpler than turbo-supercharging and required less exotic metallurgy. Britain developed sophisticated 2-stage mechanical superchargers that provided excellent high-altitude performance, though at the cost of complexity and significant power loss to drive the supercharger itself. America chose the most demanding path, turbo-superchargers, devices that used hot exhaust gases to spin turbines that drove centrifugal compressors, forcing air into engine intakes at sea-level pressure even at extreme altitude. The principle was elegant. Exhaust energy that would otherwise be wasted heating the atmosphere instead performed useful work by compressing intake air. No mechanical connection to the crankshaft meant no power drain. The engine produced its full rated horsepower, and the turbocharger added altitude capability essentially for free. But the engineering challenges were enormous. The turbine wheel spun at over 20,000 revolutions per minute, while, bathed in exhaust gases exceeding 1,500 degrees Fahrenheit, centrifugal forces created stresses measuring thousands of pounds per square inch. Any imperfection in metallurgy, any imbalance in the turbine wheel, any weakness in the high-temperature bearings would result in catastrophic failure. The turbine would disintegrate, sending shrapnel through the engine nacelle and often igniting fires that could destroy the aircraft. General Electric's development program for turbo-superchargers had begun in 1918, emerging from Dr. Sanford Moss's pioneering work at the company's Lynn, Massachusetts facility. By 1941, When America entered the war, General Electric had refined the technology through 2 decades of iterative improvement. The Type B series turbocharger, designed for the Wright R3350 engine, represented the culmination of that experience. Each unit weighed approximately 150 pounds and consisted of a turbine wheel, a compressor wheel, high-temperature bearings, and a complex system of ducts and control valves. The turbine wheel was forged from specialized nickel-chromium alloy, capable of maintaining strength at temperatures that would melt ordinary steel. Each wheel was individually balanced to tolerances measured in thousandths of an inch. The bearings used advanced lubricants that could function in temperature extremes from 40 below zero at altitude to over 400 degrees near the turbine housing. Manufacturing these components required precision beyond what most nations could achieve. General Electric's Schenectady, New York plant that produced turbochargers for B-29 engines operated with quality control systems that rejected units for imperfections invisible to the naked eye. X-ray inspection verified internal structure of turbine wheels. Vibration testing at operational speeds identified balance problems. Every turbocharger underwent full power testing before installation, ensuring it could maintain boost pressure across the entire altitude range. Production capacity matched precision. By 1944, General Electric was manufacturing over 2,000 turbochargers monthly just for B-29 production. Each Superfortress required 8 units, 1 for each of the 4 engines' twin turbocharger installation. That meant General Electric was producing enough turbochargers for 250 B-29 seconds every month, plus thousands more for replacement units, and for other aircraft like the P-47 Thunderbolt that used single turbocharger installations. Japan had none of this capability. Japanese engineers understood turbo-supercharger principles perfectly well. Nakajima Aircraft Company had obtained technical documents about American turbocharger development as early as 1941 through intelligence channels and examination of equipment that reached Japan before the war began. Japanese aeronautical engineers recognized immediately that turbo-supercharging represented a decisive military advantage. An aircraft that could operate effectively at 30,000 feet would dominate opponents limited to 25,000 feet. The altitude advantage provided immunity from interception, allowed bombers to fly above most weather, and gave fighters the ability to choose when and where to engage. But understanding the advantage and replicating it proved to be separated by an insurmountable industrial chasm. Japan's first serious attempt to develop operational turbo-superchargers began in late 1941 at Nakajima's Musashino engine plant. Engineers worked from theoretical principles and whatever fragments of information they could gather about American designs. The prototype turbochargers they produced were mechanically sound on paper. The turbine wheels were properly designed. The compressor geometry followed correct aerodynamic principles. The control systems were functional, but the metallurgy was inadequate. Japanese high-temperature alloys could not match the strength and thermal stability of American nickel-chromium steels. Turbine wheels that should have operated reliably for hundreds of hours instead failed after 20 or 30 hours of use. Sometimes they failed catastrophically, with turbine fragments punching through engine cowlings. More often, they simply lost efficiency as the high-temperature environment degraded the metal structure, causing the turbine blades to warp or crack. Even when Japanese engineers managed to produce turbochargers that functioned reliably in testing, they could not manufacture them in quantities that mattered militarily. The precision machining required for turbine wheels and bearings demanded machine tools Japan's industry was struggling to supply. Each turbocharger required dozens of hours of skilled machining time. Quality control inspections identified failure rates above 30%, meaning a third of units produced could not meet operational standards. By mid-1943, Nakajima's most optimistic production projections suggested they might manufacture 50 turbochargers monthly if they devoted substantial resources to the program. 50 units per month. General Electric was producing 40 times that quantity for American aircraft. The mathematics of that disparity were crushing. Even if Japan had suddenly solved all metallurgical and manufacturing problems, even if they could somehow produce turbochargers that matched American reliability, they lacked the industrial capacity to deploy them widely enough to matter. A nation that could build 50 turbochargers monthly faced an opponent building 2,000. That ratio defined the Pacific War as clearly as any battle. Lieutenant Fumio Niwa, an engineering officer assigned to evaluate captured American aviation equipment, examined a turbocharger removed from a B-29 that had crashed in China during 1944. His report, discovered in Japanese archives decades after the war, documented findings that revealed the technological gap with painful clarity. The American turbocharger showed machining precision that Niwa measured with micrometers. Turbine blades were uniform to within 0.002 of an inch. Bearing surfaces were polished so smooth they felt like glass. The high-temperature alloy composition was beyond anything Japanese metallurgists had achieved. Niwa's report noted that even the bolts fastening components together were manufactured to standards exceeding typical Japanese aircraft parts. He concluded that American industry possessed manufacturing capabilities an entire generation ahead of Japan's. The turbocharger represented not just superior engineering, but systematic industrial advantage across every element of production. Precision forging, advanced metallurgy, automated inspection systems, and production volume that treated complex mechanisms as mass-produced commodities rather than handcrafted components. The human cost of this technological gap became evident the first time Japanese fighters attempted to intercept B-29 seconds operating at their designed altitude. June 15, 1944. The first B-29 strategic bombing mission against Japan launched from staging bases at Chengdu, China. 75 superfortresses took off that evening, though only 47 reached the primary target at Yawata on Kyushu. The mission demonstrated both the B-29's potential and the challenges ahead. 7 aircraft were lost. 57 airmen died. Yet even this costly introduction revealed that Japanese defenses were fundamentally inadequate against high-altitude bombers. Japanese radar operators on Kyushu detected the approaching formations hours before they arrived. Air raid sirens wailed across Yawata. Pilots of the Imperial Army's 4th Sentai scrambled to their Kawasaki Ki-61 Toryu twin-engine fighters, climbing aggressively toward bombers flying at altitudes between 8,000 and 21,000 feet. Even at these relatively modest heights, dictated by fuel constraints on the long mission from China, Japanese interceptors struggled. Their Nakajima Ha-25 engines, rated at 1,080 horsepower each at sea level, lacked effective turbo-supercharging. Above 20,000 feet, these engines produced perhaps 60% of rated power. Warrant Officer Sadamitsu Kimura managed to close on one B-29, the aircraft designated Plumber Dragon with 12 crew aboard. His attack succeeded, sending the superfortress down in flames with no survivors. But this lone victory came at terrible cost. Kimura expended nearly all his ammunition and barely returned to base with his engine overheating dangerously at altitude. Around him, other Japanese pilots fired desperately at silver bombers, but most attacks failed to inflict damage. The B-29's defensive armament, controlled by advanced fire control systems, responded with devastating accuracy. Captain Teruhiko Kobayashi, the same pilot who would later struggle to reach B-29 seconds over Tokyo, documented the frustration in his unit's reports from that first mission. American bombers operated at altitudes where Japanese fighters barely maintained level flight, let alone maneuvered for combat. The B-29's speed at altitude, approximately 350 miles per hour, matched what Japanese interceptors could achieve in thin air above 25,000 feet. Even reaching bombing altitude cost fighters excessive fuel, leaving minimal time for combat and engines running so hot that catastrophic failure threatened constantly. The American crews flying those missions understood they held an advantage, but many hadn't fully grasped its magnitude. Technical Sergeant Robert Williams, a gunner on the B-29 City of San Francisco, later recalled watching Japanese fighters attempting interception during that first Yawata raid. The enemy aircraft climbed toward the bomber stream with what seemed like agonizing slowness. By the time they reached formation altitude, the Japanese fighters were moving so slowly they appeared to hang in the air. When they attempted attack runs, their maneuvers were sluggish, almost dreamlike. Williams's central fire control system allowed him to track targets with computer-assisted lead calculation. He watched tracers reach out toward a Ki-45 that seemed unable to evade. The Japanese fighters' return fire appeared to fall short, the bullets losing velocity in the thin air. The technological advantage wasn't just about altitude capability, it was about the systematic integration of every element required to operate effectively in the stratosphere. While Japanese pilots struggled with crude oxygen systems that frequently malfunctioned, American B-29 crews breathed normally inside pressurized cabins. The Superfortresses cabin maintained pressure equivalent to 8,000 feet altitude, even when flying at 30,000 feet. Crew members wore regular flight suits rather than bulky high-altitude gear. They could move freely through the aircraft, access systems, and tend to wounded without the confusion and disorientation that came from oxygen deprivation. Japanese pilots at 30,000 feet endured temperatures 40 degrees below 0 Fahrenheit. Their electrically heated flight suits rarely worked properly. Fingers went numb despite gloves, making it difficult to manipulate gun triggers or control sticks. Oxygen masks froze to faces. Canopies frosted over, limiting visibility. And worst of all, the oxygen systems themselves were unreliable. Japanese oxygen equipment was primitive compared to American standards, consisting of simple regulators that often failed at extreme altitude. Pilots experienced hypoxia, the insidious oxygen deprivation that impaired judgment without obvious symptoms. Men would make poor tactical decisions, fail to recognize dangerous situations, or simply become too confused to function effectively. Major Makoto Ogawa, who eventually became one of Japan's most successful B-29 hunters with 7 confirmed kills, later described the overwhelming disadvantage Japanese pilots faced. Americans flew in a realm where Japanese aircraft barely functioned. The B-29 crews enjoyed heated compartments, reliable oxygen, clear visibility, and aircraft that performed close to their design specifications. Japanese pilots endured cold that numbed their extremities, oxygen systems that left them hypoxic and disoriented, gun barrels that froze, ammunition belts that jammed, and engines that ran so rough they constantly feared flameouts. The disparity extended to every detail of high-altitude operations. American crews wore standardized pressure suits for extreme altitude missions, garments that could maintain body pressure if cabin pressurization failed. Japanese pilots had no equivalent equipment. If a Japanese fighter's canopy failed at altitude, the pilot would lose consciousness within seconds from explosive decompression. American bomber formations flew with precision navigation equipment that allowed them to find targets regardless of weather or visibility. Japanese fighters relied on ground control radio instructions that often failed at extreme altitude due to radio equipment limitations. By August 1944, Japanese intelligence had compiled disturbing reports about American bomber capabilities. Interrogation of captured B-29 crewmen, analysis of wreckage, and pilot observations painted a picture of technological superiority that shocked military leaders. The B-29 wasn't simply a large bomber. It was a flying weapons system incorporating innovations Japan could not match. The Turbo-Superchargers that enabled high-altitude operation were just the foundation. Built upon that foundation was pressurized crew compartments, remote-controlled defensive turrets, advanced fire control computers, radar bombing systems, and structural engineering that produced an aircraft capable of absorbing battle damage that would destroy Japanese bombers. Colonel Takushiro Hattori, an operations officer at Imperial General Headquarters, wrote in his diary that month about the implications of B-29 raids. American bombers operated with impunity at altitudes Japanese fighters could not effectively reach. The few interceptors managing engagement reported that even when scoring hits, the B-29's rugged construction absorbed damage that would destroy Japanese aircraft. Most alarming was the realization that these raids represented only the beginning. American production capabilities suggested thousands of B-29 seconds would eventually attack Japan, each one beyond effective defensive reach. The mathematics of interception had turned catastrophically against Japan. A fighter climbing from ground level to 30,000 feet consumed approximately 30 minutes, and burned a third of its fuel load. At altitude, fighter performance degraded dramatically. Guns, while deadly at close range, required pilots to close within a few hundred feet of targets, a maneuver made nearly impossible by reduced aircraft performance and B-29 defensive fire. Even successful interceptions often cost irreplaceable experienced pilots who died when damaged or fuel-depleted fighters crashed attempting to return from extreme altitude. Japanese aircraft designers desperately sought solutions. The Nakajima Ki-61, developed specifically as a high-altitude B-29 interceptor, incorporated a turbo-supercharged Nakajima Ha-219 engine intended to deliver effective performance above 30,000 feet. On paper, the design was impressive: service ceiling above 40,000 feet, heavy armament of 30mm and 20mm cannon, and speed sufficient to overtake B-29 formations. Only one prototype flew before war's end in April 1945, demonstrating severe problems. The turbocharger, cobbled together from inadequate materials with insufficient testing, failed repeatedly. Even functioning, it delivered inconsistent performance. The project died not from lack of engineering skill, but from lack of industrial capacity to produce reliable turbochargers. The Tachikawa Ki-94, another proposed high-altitude interceptor, never progressed beyond mock-up stage. The Mitsubishi J-8M, a rocket-powered interceptor based on the German Me-163 Comet, offered high-altitude capability without turbochargers, but dangerous rocket fuel and extremely short endurance made it impractical for defending against B-29 raids. Japan's finest aeronautical engineers understood what was needed, but lacked the industrial foundation to produce it. What made the situation truly desperate for Japan was that the B-29 represented not an isolated technological achievement, but the output of an integrated industrial system operating at a scale Japan could never match. Boeing's factories were producing B-29 seconds at rates that would have seemed impossible to Japanese planners. The Renton, Washington plant alone delivered over 100 Superfortresses monthly by late 1944. Boeing's Wichita, Kansas facility produced similar quantities. Martin's Omaha plant added more. Bell's Marietta, Georgia assembly lines contributed additional aircraft. Total production exceeded 200 B-29 seconds per month, each one requiring 8 turbochargers, tens of thousands of precision components, advanced electronics, and assembly by workers whose productivity stunned Japanese observers. A single B-29 contained approximately 55,000 individual parts. Not counting rivets and fasteners, building one required 45,000 worker hours. Yet American industry was delivering over 200 monthly while simultaneously producing thousands of fighters, hundreds of other bombers, tens of thousands of trucks, and all the other material needed to fight a two-ocean war. Japanese planners who saw these production figures in intelligence reports initially assumed they were errors or propaganda. The numbers seemed physically impossible. Japan's entire aircraft industry was producing roughly 1,500 aircraft monthly of all types combined by late 1944, and that production rate was declining under the strain of raw material shortages and bombing disruption. The strategic implications became undeniable on November 24, 1944, when the first major B-29 raid struck Tokyo from the newly captured Mariana bases. Lieutenant Colonel Robert K. Morgan, the same pilot who had commanded the Memphis Belle in Europe, now led 111 Superfortresses of the 73rd Bomb Wing on the 1,500-mile mission from Saipan to Japan's capital. The instruments before him told a story Japanese intelligence officers had desperately hoped wasn't true. The turbo-supercharger boost gauges climbed steadily as Morgan's aircraft, Dauntless Dottie, reached operational altitude. At 31,000 feet, the Wright R-3350 engines were producing their full 2,200 horsepower, maintained at sea-level power by the twin General Electric turbochargers on each engine. Below and far behind, Japanese fighters struggled upward through increasingly thin air, their engines gasping, their pilots growing hypoxic, their commanders realizing that everything they'd feared about American technological superiority was demonstrably true. The Mariana bases changed everything. Unlike missions from distant China that required aircraft to fly 1,000-mile approaches over hostile territory, the Marianas lay only 1,500 miles from Tokyo. B-29 seconds could reach Japan with full bomb loads, fight through defenses, and return with fuel reserves. They could fly regularly, building a sustained campaign rather than isolated raids, and they could operate from bases that American construction battalions had transformed into massive aviation facilities in a matter of months. Sergeant Shoji Suzuki, an anti-aircraft gunner stationed near Tokyo, kept a diary documenting the growing despair among defenders. Initially, his unit engaged B-29 formations with confidence. Their 75mm guns could fire shells to altitudes around 25,000 feet. But American bombers often flew higher, beyond gun range, or approached at angles giving gunners insufficient tracking time. More frustrating, even direct hits rarely brought down B-29 seconds. The bomber's structure, built with redundant systems and armored in critical areas, withstood damage that would have shredded Japanese aircraft. Suzuki recorded watching crippled B-29 seconds trailing smoke with engines shut down, continuing toward targets and often returning safely to base. The psychological impact on Japanese defenders was perhaps more devastating than the physical destruction. Every raid demonstrated that Japan could not protect its cities, could not stop American bombers, could not contest control of the air above the homeland. The silver formations that appeared regularly over Tokyo, Osaka, Nagoya, and Kobe flew with an apparent invulnerability that shattered Japanese confidence. Air raid sirens that once sent people scrambling for shelters now triggered resignation. The bombers would come. Some would drop their weapons. A few might be damaged or destroyed by desperate interception attempts, but most would complete their missions and return safely to distant Mariana bases that Japan could not strike. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Japanese efforts to improve air defenses focused on fighter performance modifications, but every attempt ran into the same fundamental limitations. The Kawasaki Ki-61 high-end, powered by a liquid-cooled Ha-40 engine, could reach altitudes around 32,000 feet, higher than most Japanese fighters. But climb rate was insufficient, and engine reliability so poor that many Ki-61 seconds were grounded awaiting spare parts that would never arrive. The Nakajima Ki-84 Hayate, introduced in 1944, represented Japan's best mass-produced fighter. It featured the Nakajima Homare engine, a complex radial design delivering good performance at altitude when properly maintained. However, the Homare's intricate construction made it maintenance-intensive, and quality control problems meant many engines failed prematurely. The Ki-84's theoretical performance was impressive. Maximum speed around 400 miles per hour at 20,000 feet, service ceiling near 35,000 feet, and heavy armament of 20mm and 30mm cannon. In practice, few Ki-84 seconds achieved these specifications. Poor quality fuel damaged engines, crude lubricants broke down at low temperatures, and manufacturing defects caused frequent failures. American pilots who test flew captured Ki-84 seconds after the war praised the handling and performance, noting it matched or exceeded American fighters in some respects. But they also observed that these captured examples had been selected for exceptional condition, maintained by skilled Japanese mechanics using hoarded high-quality materials. The average operational Ki-84 performed far below design specifications. Even when Japanese fighters reached B-29 operating altitudes, they faced the bomber's sophisticated defensive armament. Each superfortress mounted 10 50-caliber machine guns in remote-controlled turrets. A central fire control system allowed gunners to coordinate fire, concentrating multiple turrets on single targets. The system incorporated computing sites that automatically calculated lead and deflection, significantly improving hit probability. Japanese pilots quickly learned that approaching within effective gun range of a B-29 formation meant flying through coordinated barrages few survived. Captain Yasuhiko Kuroe, a veteran fighter pilot with the 302nd Air Group, wrote in a letter discovered after the war that fighting B-29 seconds felt like attacking a fortress. Bombers absorbed punishment that would destroy a dozen Japanese aircraft. Their crews were protected by armor and redundant systems, while Japanese pilots flew unarmored fighters with vulnerable fuel tanks and minimal protection. The disparity wasn't just technological, it was philosophical. American aviation doctrine emphasized crew survivability. Armor plates protected pilots. Self-sealing fuel tanks prevented fires. Redundant control systems allowed damaged aircraft to limp home. Japanese doctrine had traditionally emphasized offensive power over protection, assuming pilot skill and fighting spirit would overcome material disadvantages. Against B-29 seconds operating at unreachable altitudes with defensive firepower that shredded attacking fighters, that philosophy proved catastrophically inadequate. December 1944 brought increasingly desperate Japanese responses. When 86 B-29 seconds attacked the Musashino aircraft plant in Tokyo, Japanese defenses managed to shoot down or damage several bombers, but at terrible cost. The 244th Sentai, led by Captain Kobayashi, claimed 6 B-29 seconds destroyed through ramming attacks, but lost multiple irreplaceable pilots in the process. Ramming became increasingly common as Japanese pilots realized conventional attacks often failed to bring down the massive bombers. The tactic was suicidal by design. Pilots aimed fighters at B-29 wing roots or tail assemblies, hoping to destroy control surfaces, then attempted to bail out before impact. Few survived. American crews respected the fanatical courage of Japanese pilots, even as they were horrified by the waste of lives. Technical Sergeant John McLaughlin, a gunner on City of Los Angeles, later recounted watching a Japanese fighter deliberately ram the B-29 flying beside his aircraft. The fighter struck the bomber's tail, shearing off the entire vertical stabilizer. Both aircraft fell from formation in uncontrolled spins. McLaughlin saw no parachutes. He later learned the B-29 crew, 10 men, died in the crash. The Japanese pilot's name was never known, one of thousands who died defending their homeland against an enemy they could not defeat. By early 1945, Japanese air defenses had deteriorated near collapse. Fuel shortages grounded many fighters. Experienced pilots had been killed in staggering numbers, replaced by teenagers with minimal training who stood no chance against veteran B-29 crews. American fighter escorts, P-51 Mustangs flying from Iwo Jima after its capture in March 1945, made defending against B-29 raids even more hopeless. Japanese interceptors climbing slowly to altitude became easy targets for P-51 seconds that could outclimb, outrun, and outfight any Japanese fighter. The Turbo-Superchargers that gave B-29 seconds their altitude advantage also enabled the P-51 seconds that escorted them. Each Mustang carried a single turbo-supercharger installation on its Packard-built Merlin engine, allowing it to maintain performance above 30,000 feet. When Japanese fighters struggled upward to intercept B-29 formations, they encountered not just the bomber's defensive fire, but also American fighters that could operate effectively at altitudes where Japanese aircraft barely functioned. The combination was devastating. In a typical engagement during early 1945, Japanese interceptors would climb for 30 minutes to reach bomber altitude, arrive with reduced fuel and overheating engines, attempt attacks against concentrated defensive fire, and then face P-51 escorts that could engage them at will. Japanese fighters that survived the initial contact often lacked fuel to return to base. Pilots who successfully disengaged found themselves alone, disoriented from hypoxia, flying damaged aircraft that might not survive the descent to lower altitude. The night of March 9th to 10th, 1945, marked a tactical shift that demonstrated the B-29's versatility beyond high-altitude operations. General Curtis LeMay, commanding 21st Bomber Command, ordered a radical change in tactics. Instead of precision bombing from high altitude, 334 B-29 seconds would attack Tokyo at night from altitudes around 7,000 feet, carrying incendiary bombs designed to start fires. The decision was controversial within American command circles. Lower altitude exposed bombers to heavier anti-aircraft fire and eliminated the safety margin that altitude provided. But LeMay calculated that Japanese night defenses were weak, and lower altitude would eliminate turbo-supercharger stress, reduce engine overheating issues, and allow each B-29 to carry vastly more bombs. Results exceeded LeMay's expectations and horrified even some of the crews who executed the mission. In 3 hours, American bombers dropped nearly 2,000 tons of incendiaries on Tokyo's crowded residential districts. Firestorms developed, creating winds that sucked oxygen from shelters and generated temperatures exceeding 1,800 degrees Fahrenheit. An estimated 100,000 people died that night, more than either atomic bombing would later kill. 16 square miles of the city burned to ash. Only 14 B-29 seconds were lost, remarkably low given the raid's intensity and the fact that aircraft were flying at altitudes where Japanese defenses should have been effective. The Tokyo firebombing demonstrated that even without exploiting high-altitude capability, B-29 seconds could devastate Japan. But the low-altitude tactics were possible only because earlier high-altitude operations had established American air superiority. The precision daylight raids from 30,000 feet had destroyed Japanese fighter production facilities, damaged aircraft engine plants, and forced Japan to disperse its aviation industry into small facilities that operated inefficiently. By March 1945, Japan was producing fewer than 1,000 aircraft monthly, and many of these were training aircraft or obsolescent designs built because factories lacked materials for modern fighters. The cumulative effect of the strategic bombing campaign was economic collapse. Japanese war production, already declining under resource shortages and naval blockade, fell precipitously through early 1945. Transportation networks were destroyed, making it impossible to move resources even where they existed. Workers abandoned factories to flee burning cities or search for food in rural areas. The government lost control of economic planning as industries dispersed or ceased operation entirely. Major General Arisu Seizo, chief of Japanese military intelligence, admitted after the war that by June 1945, his analysts recognized defeat was inevitable. American air supremacy was absolute. The B-29 campaign had destroyed Japan's ability to wage war. Aircraft production had collapsed, oil refineries were obliterated, transportation infrastructure was shattered, urban industrial areas were burned out. Yet the government, trapped by military honor codes forbidding surrender and fearing the consequences of capitulation, continued fighting until atomic bombs provided justification for ending the war. The atomic bombings of Hiroshima on August 6 and Nagasaki on August 9, 1945, marked the end of World War II in the Pacific. Both atomic weapons were delivered by B-29 seconds. The Enola Gay, flying at 31,000 feet over Hiroshima, operated at altitude made possible by 8 General Electric Turbo-Superchargers, maintaining engine power in thin air. Even at war's end, with Japanese defenses essentially non-existent, the altitude capability provided by Turbo-Superchargers offered protection against remaining anti-aircraft fire and allowed the crew to escape atomic blast effects. The aircraft that dropped the second in atomic bomb on Nagasaki, Bockscar, flew the same high-altitude profile, relying on the same turbo-supercharger technology that had enabled the entire strategic bombing campaign. Post-war interviews with Japanese fighter pilots revealed a consistent theme of admiration mixed with frustration and bitterness. They respected American engineering and recognized that no amount of pilot skill could overcome technological disadvantage. Lieutenant Isamu Sasaki, who survived the war with 3 B-29 kills, one of the highest tallies any Japanese pilot achieved, later reflected that his successes came only when circumstances were perfect. Surprise attacks from above with the sun behind him, against isolated bombers separated from formations, with sufficient fuel and ammunition, and with his aircraft functioning at peak performance. Against formations flying at altitude with alert crews and fighter escorts, even the best Japanese pilots rarely succeeded. The development of high-altitude aviation capability had been pursued by many nations before World War II, but execution separated aspirations from achievement. Germany developed turbo-superchargers experimentally but never successfully deployed them operationally, focusing instead on mechanical superchargers, which were simpler but less efficient at extreme altitude. Britain relied primarily on sophisticated multi-stage mechanical superchargers, providing good high-altitude performance without turbocharging complexity. America alone made turbo-supercharging standard equipment on heavy bombers and some fighters, accepting additional complexity, cost, and maintenance burden in return for unprecedented high-altitude capability. This decision reflected American industrial confidence and capability. Turbo-superchargers required precision manufacturing that demanded advanced machine tools, metallurgical expertise, and quality control systems. They required regular maintenance by skilled mechanics with specialized training. They required steady supply of spare parts and replacement units. America possessed the infrastructure to support these requirements across thousands of aircraft operating globally. Japan did not, and could not develop it under wartime conditions. Even if Japanese engineers had designed perfect turbo-superchargers in 1941, the nation lacked the manufacturing base to produce them in quantity, the maintenance organization to keep them functioning, and the supply system to provide necessary spare parts. The post-war United States Strategic Bombing Survey concluded that the B-29 campaign was decisively effective in destroying Japan's capacity to wage war. While survey authors debated whether Japan would have surrendered without atomic bombs or the planned invasion, they unanimously agreed that by August 1945, American air supremacy was complete and Japanese defenses were shattered. The B-29's technological advantages, particularly high-altitude capability enabled by turbo-superchargers, made this outcome inevitable once sufficient bombers became available and bases within range of Japan were secured. Japanese records captured after the war revealed the extent to which B-29 raids dominated military planning from late 1944 onward. Imperial General Headquarters devoted enormous resources to air defense, pulling fighter units from other theaters, constructing thousands of anti-aircraft positions, and training tens of thousands of troops for airfield defense. None of these efforts proved effective against bombers operating beyond defensive reach. The resources expended on air defense, resources Japan desperately needed for other purposes, were largely wasted because Japanese industry could not produce the fundamental technology needed to contest control of the stratosphere. The final B-29 mission against Japan flew on August 14, 1945, the day before surrender was announced. More than 300 superfortresses attacked targets near Tokyo, encountering virtually no opposition. Japanese fighters remained on the ground, either lacking fuel or conserving resources for the expected American invasion that would never come. B-29 crews returned to their Mariana bases, not yet knowing the war was effectively over, their missions completed through the cumulative destruction of hundreds of raids Japan could not prevent or effectively counter. In the decades following the war, aviation historians and aeronautical engineers conducted extensive analyses of B-29 technological advantages. The consensus was clear and remains undisputed. Turbo-supercharging provided the fundamental capability that made strategic bombing of Japan possible from remote bases. Without this technology, B-29 seconds would have been limited to operations at altitudes around 20,000 feet, well within range of Japanese fighters and anti-aircraft guns. Losses would have been unsustainable. The entire strategic concept of bombing Japan from Mariana bases 1,500 miles away would have been impractical. The lessons Japanese engineers learned from examining American aviation technology influenced post-war Japanese industrial development in profound ways. The emphasis on precision manufacturing, systematic quality control, and rigorous engineering that characterized American turbo-supercharger production became hallmarks of Japan's post-war economic transformation. Former aviation engineers moved into civilian industries, bringing hard-won understanding of advanced manufacturing techniques. Companies like Toyota adopted production methods that emphasized quality and efficiency, principles these engineers had recognized in American aviation manufacturing but had been unable to implement during wartime. Lieutenant Toshio Ota, a technical intelligence officer who survived the war and later became an industrial consultant, wrote in the 1960s about examining captured American aviation technology. Every system, every component demonstrated manufacturing quality and engineering sophistication that had been beyond Japanese capabilities during the war. Turbo-Superchargers particularly impressed him because their operation was conceptually simple. Using exhaust energy to compress intake air was not a mysterious principle, yet execution required precision manufacturing, advanced metallurgy, and quality control that Japan's war-damaged industry could not achieve. Even had Japan somehow obtained complete turbo-supercharger designs in 1941, Ota concluded, the nation lacked the industrial base to produce them in useful quantities. The human cost of this technological gap was staggering and remains difficult to fully quantify. Japanese pilot training programs, once rigorous and producing superb aviators, had collapsed by 1945. Fuel shortages meant student pilots received perhaps 50 hours of flight training compared to 200 to 300 hours American pilots received. These inadequately trained pilots flew obsolescent aircraft against opponents who enjoyed every conceivable advantage. In July 1945, during one major engagement over the inland sea, Japanese fighters attacked a formation of over 100 B-29 seconds. American records show perhaps 2 bombers damaged, while Japanese forces lost 23 fighters destroyed with minimal damage inflicted on the bomber stream. The B-29 campaign ultimately delivered 147,000 tons of bombs on Japanese targets, destroyed 40% of urban industrial areas in 66 cities, and killed an estimated 330,000 civilians. Japanese war production collapsed completely by summer 1945. The government could no longer coordinate economic activity. Industries ceased operation or operated at tiny fractions of capacity. Transportation networks were destroyed. Food distribution broke down, causing widespread hunger even before surrender. The strategic bombing campaign had achieved what blockade and ground invasion might have accomplished more slowly and at far greater cost in American lives. The Boeing B-29 Superfortress flew its last combat mission in 1954 during the Korean War. By then, jet-powered bombers were replacing propeller-driven aircraft, and turbo-supercharging for piston engines had become obsolete technology. But the B-29's legacy endured in military doctrine and industrial practice. It demonstrated that technological superiority could overcome numerical inferiority, that industrial capacity was as important as individual courage, and that air power alone could destroy a nation's ability to wage war without requiring ground invasion. Today, only 2 B-29 seconds remain airworthy, preserved and maintained by dedicated organizations, ensuring future generations can witness these historic aircraft. When these bombers fly at airshows, there are 3,350 engines producing that distinctive deep-throated roar. Few spectators realize that hidden within each engine nacelle are turbo-superchargers, survivors of the technology that helped end history's most destructive war. Those components, spinning at thousands of revolutions per minute as the B-29 seconds climb toward altitude, still perform the function they were designed for 8 decades ago, compressing air to maintain engine power in thin atmosphere, just as they did over Japan when the outcome of the Pacific War hung in balance. The story of Japanese forces facing B-29 superfortresses ultimately demonstrates how industrial capability and technological development determined modern warfare outcomes far more decisively than traditional military virtues, courage and tactical skill. The turbo-superchargers that allowed B-29 seconds to operate at 30,000 feet were more than mechanical devices. They were products of an entire industrial system, the metallurgical science that created high-temperature alloys, the precision, manufacturing that produced turbine wheels balanced to thousandths of an inch, the quality control systems that tested every unit, the production capacity that manufactured thousands monthly, the supply network that delivered spare parts globally, the training programs that taught mechanics to maintain complex equipment, the engineering culture that solved problems systematically rather than through individual improvisation. Japan possessed brilliant engineers, courageous pilots, and determined defenders. What it lacked was the integrated industrial capability to match American technological advantages across the full spectrum of modern warfare. The B-29's turbo-superchargers symbolized that disparity more clearly than any other single technology. When those silver bombers cruised at 30,000 feet over Japan, their turbo-superchargers spinning silently within engine nacelles while maintaining sea-level power in stratospheric air, they carried more than bombs. They carried proof that industrial might had become the decisive factor in 20th century warfare, and that America possessed that might in quantities no enemy could match. Japan never expected this reality when it attacked Pearl Harbor in December 1941. The decision to wage war against America was based on assumptions about American industrial capacity, technological capability, and national will that proved catastrophically wrong. Japanese military planners believed American society was too individualistic, too soft, too divided to sustain a long war. They believed Japanese superiority in pilot training and fighting spirit would overcome material disadvantages. They believed America's industrial strength could be negated by destroying its Pacific Fleet and seizing resource-rich territories before American production reached full scale. Every assumption proved false. American industrial capacity exceeded Japanese estimates by orders of magnitude. American technological development produced innovations like turbo-superchargers, radar, proximity fuses, and countless other systems Japan could not replicate. American national will, rather than fracturing under attack, unified with determination that sustained the war effort through nearly 4 years of global combat. And once that industrial machine reached full production, once the technological advantages were deployed in quantity, once American forces established positions from which they could strike Japan directly, the outcome became inevitable. The B-29 Superfortress represented the culmination of these advantages. An aircraft designed from first principles to attack Japan from remote bases, an aircraft incorporating every technological edge American industry could provide. An aircraft that could fly higher, faster, farther, and with greater payload than anything Japan could field. And an aircraft whose most critical advantage, the ability to operate at altitudes where Japanese defenders could not effectively reach, depended fundamentally on 8 turbo-superchargers that represented everything American industry did well and everything Japanese industry could not match. When B-29 seconds appeared over Tokyo at 31,000 feet on that November morning in 1944, they announced a new reality that Japanese military leaders had feared but could not prevent. The war was already lost. Not lost on any single battlefield, but lost in the factories, laboratories, and training facilities where America's industrial civilization had created military capabilities Japan could not counter. The silver bombers flying serenely beyond defensive reach were merely the visible manifestation of that underlying truth. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.